Some work does not arrive as one job. It arrives as 100 small ones all day from somewhere else. A queue is where that work waits, and this is how you use one. The designer is one half of a workspace. The other half is the admin console. Robots, vaults, schedules, everything a flow needs that is not itself a flow. Queues live here because a queue belongs to the workspace rather than to any one flow. One row for each queue, and a count of its items in each state they pass through. Let us make one for refund requests. A queue needs a name, and the name is the whole contract. It is the string a queue node will ask for, in any flow, on any robot. No schema, no size, no retention policy. A queue is a name and a list. Before a single item goes on that queue, there is one thing to settle. Queue items are encrypted, and the key is yours. It lives in a vault in this workspace. A vault of its own, named for what it holds. The vault secret key is shown once here and never again. Copy it somewhere durable now. It was generated in the browser, and the server never had it. Inside the vault goes one item. An AES key, one key used to encrypt an item and to read it back. The key itself is generated for you. All you choose is the name. That name is what a queue node will list when you point it at a key. A robot cannot read that vault either until you hand it this vault's key. The console asks for your account password first because it is about to unwrap a secret. Then the vault and the key you copied a moment ago. The browser encrypts it with that robot's own public key, so nothing readable crosses the network. Now the flow that fills the queue. It starts the way every flow starts. A function node stands in for wherever the work really comes from. 3 refund requests. Each one is a plain object. A ticket number, a customer, an order, and amount. Add item puts one object on a queue, so the flow walks the list and adds them one at a time. For each hands the node a single request, and add item says which queue it belongs on. The same name we typed in the console, and at most 3 attempts for any one item. An item is any JSON object, whatever shape the work has. And the ID key names the field that makes an item unique. Add the same ticket twice, and the queue refuses it. Go to sends the message back to the label, and for each hands over the next request. It is what starts the loop as well. The first message comes straight off the list. When there are no requests left, the lower output of for each ends the flow. One property on that node is still empty, and nothing works without it. The AES key. You cannot type into a credential property, it holds a reference. Which vault and which item? The robot fetches the key itself at runtime. Which is why the key never appears in the flow and never reaches the repository. Save because the robot runs the saved flow rather than the one on your screen. Run it on the robot. The robot builds each item, encrypts it with the key from the vault, and posts it. What the server stores is ciphertext. It has no key, and it never will. Back in the console, the queue has 3 items in the new column. Every item on a queue is a transaction, and the console keeps all of them. An item ID, the reference you chose, a priority, a status, and how many attempts it has had. What is not here is the request itself. The console has no key to read it with. That is the trade the vault buys you. Full visibility of what happened, none of what it said. The other half is a flow that takes work off the queue. Another label, another loop. Get next item asks the queue for one item, and decrypts it with the same key. Start transaction is ticked, so the item is marked in progress the moment this robot takes it. No other robot will be handed the same request. When the queue has nothing left, get next item comes back empty. A switch asks whether we got one. Its second output is the empty case and stops. The first output carries an item, and this is where the real work would go. Hours checks one thing. Does the request carry an order number to refund against? A second switch splits on the answer. Either way the queue is told. Update item state takes the item ID and a new status. Successful when the refund went through. Failed when it did not, and a failed item still has attempts left, so it comes back. Go to sends the message back to the label, and the robot asks for the next item. Both branches end there, so whatever happened to an item, the robot goes back for another. And the stop that ended the intake is replaced by a go-to of its own, pointing at the same label. Filling the queue runs straight into working it, 2 halves, 1 flow. Run the whole thing. The intake runs again, then the loop turns until the queue has nothing left to give. 1 item at a time, each one taken, worked, and written back. And the console has the whole story. 2 of the 3 refunds went through, 1 did not. The failed one is the request with no order number, and it has had 1 try out of 3. A person can put it back by hand, change its status, or give it another try. That is what a queue is for, not the list, the record of what happened to every item. A queue has no schema and no configuration. The name is how flows find it. The items on it are encrypted with a key from your vault, so the platform stores what it cannot read. And every item carries its own history, which is what makes 100 small jobs something you can manage. 1 flow fills the list, and any number of robots work it off. Thank you for watching.